And now we want to find the arc length of a curve that is represented by parametric equations instead of by the equation y equal to f of x. And so when we have a curve or a graph that's represented by the function y equal to f of x, then the length, the arc length is the formula definite integral from a to b of the square root of 1 plus derivative of f of x squared. And now we want to develop a formula for finding the arc length of a curve that is represented by parametric equations. So we'll start right here. The derivative of f of x, or f prime of x, can also be written as dy dx. So dy dx is the same as f prime of x. And by the chain rule, dy dx can be written as dy dt divided by dx dt. And now we separate them. This becomes dy dt squared dividing by dx dt squared. Dx is the same as dx dt times dt. And then this part right here, so 1 plus dy dt squared divided by dx dt squared, and so we want to add them. So the common denominator is dx dt squared, meaning this, we can multiply this by dx dt squared divided by dx dt squared. So this is just 1. But now this becomes, the common denominator is now dx dt squared. And then the top we have dx dt squared plus dy dt squared. And so that's how we got from here to here. And then dx dt is the same as the square root of dx dt squared. And so square root of square, and we just get dx dt. And then now this is under the square root, so we can move this dx dt squared inside. So it's the same as dx dt squared. But these two right here will cancel out. So the dx dt squared will cancel out with this dx dt squared. And so what's left is just dx dt squared plus dy dt squared. And this is the formula for finding the arc length of a curve represented by parametric equations. Now let's look at an example. So here we have the parametric equations of x equal to 6x, 6t plus 2, y equal to 3t, and we want to find the arc length on the interval from 0 to 2. And on the graphing calculator, when we graph this set of parametric equations, this is what the graph looks like. This is from 0 to 2. So notice when t is 2, then x is 6 times 2 plus 2, which is 14. And when x is 0, when t is 0, x is 2. So that's why on the graph we see that it runs from 0 to 2. And so to get the derivative, first we need dx dt. So dx dt be just 6 plus 0, which is 6. And the next we need dy dt, and be just 3. And the arc length will be the integral a to b dx dt squared plus dy dt squared dt. So t runs from 0 to 2, and this is 6, and this is 3. This is 36 plus 9, which is 45. And then the antiderivative, the constant 45, just the square root of 45 times t. And then we need to evaluate this from 0 to 2. And when we do that, this comes out to be 2 times the square root of 45. So the length of this arc is 2 times the square root of 45.